Hello class, welcome to the next segment in the week 6 material. And in this segment, we're going to talk a little bit about some functions that are actually built into Python. And that is to say that we don't need an import statement to read in these functions from an external module. So these are functions that we can run that are part of Python and don't require any sort of import statement to actually use. And we've sort of seen some examples of this already. In fact, the print function, which we introduced way back in week 1, is in fact a built-in function, and the value that we give the print function is just something that we want to see in the console when the program gets to that point in the program. So we put something into the print function, and the result that we get back will be some fancy stuff that appears in the console. But there are several other functions that sort of operate the same way in that you don't need an import statement to actually make use of them. And the first of which that we're going to introduce is the one on line 7 here, which is the min function. And the min function, you give it a list of numbers, and the function itself will give you back the smallest number out of the list that you give it. So in this case, we're only giving the min function two numbers here, the 30 and the 70. And between those two numbers, the smallest number is going to be this 30. So the end result of the min function will just be 30, which is the smallest number out of the list of numbers that we gave that function. And since this is on the right-hand side of an equal sign, then there must be a variable on the left-hand side, which is holding on to the result we get back from that function. So this variable called the min will hold on to the result we get back from this function, which if the min function does what we think it does, that should just be 30. The min should just be 30. Max function, sort of the same idea, except here, instead of picking out the smallest number out of the list of numbers that you give it, it will pick out the largest number. So between the two numbers that we give the max function here, the largest number is just this 70, and that'll become the end result on the right-hand side of the equal sign, which then goes on the left-hand side of the equal sign, in this case, a variable called the max. Another such function, which is the abs function, which essentially just takes the absolute value of a number that you give it, which is just a really fancy way of saying you give it a number and it makes it positive. So abs of 30 will give you back a result of positive 30, and then abs of negative 30 will also give you back a result of positive 30. And if we want to, we can sort of confirm what exactly is going on here. So let's first get the min. So if that is in fact doing what we expect, then the min should just be 30, which it is. And then we can also check the value of the max, which if that's doing what we expect, then that should just be 70, which it is. And then finally, the absolute value, the variable that's holding onto the result we get back from this. So that should also be 30, which it is. And if I try abs of negative 30, that should also be positive 30, which is in fact a result we can confirm. So some other functions that we can work with. This one is kind of interesting, and we're going to talk a lot more about this when we get into the week 7 unit. This open function, that is something that allows us to work with external files. So if we have, say, a spreadsheet file that is holding on to some sort of data set, then we could have the Python program open that file, read in its contents into the program itself, and then have our program do something with the contents of those files. And we're going to actually go into much greater detail on how exactly this works in the week 7 unit, but this is just to sort of illustrate again how the open function is just one such function that we can work with. Again, this requires no import statement, which is really nice. I think Python is the only programming language that doesn't require any sort of import statement to actually work with external files, which is really, really nice. But this actually, if you really want to know what all this does here, this actually just opens the contents of this Python file, that is the text of this Python code, and just prints the contents of the file to the screen. So it just actually reads in the content. This Python program reads in its own contents and prints out those contents to the screen when we run this print statement on line 17. Again, we'll talk a lot more about this open function in the week 7 unit when we start talking about how to work with external data files. Now there are some functions, so you notice how each of these functions turns purple when it's written out in Python code. But there are some functions that don't turn purple, and they are in fact specific to certain data types. And one such function is the append function, which is something that you can use on lists. So here we have a list defined on line 28. Again, the idea of lists is something that we covered in week 5. And again, square brackets denotes the starting point, ending point of the list, and every entry in the list is separated by commas. And when we use the append function here, so the way that works is we type the name of the list followed by a dot, and then append, and then parentheses, and then the number that we put in the parentheses is the item that we want to add to the list. So what the append function actually does is it takes the value in the parentheses here, what I have highlighted, and adds it to the end of the list. So right now the list is 3, 1, 4, 1, 5. After running what's on line 29 here, this 9 will actually be put in the list as a new entry. So the list will actually be 3, 1, 4, 1, 5, 9 after running what's on line 29 here. And then same idea on what's line 30. So this actually does modify what is in this variable called the list. This will actually modify the original list. This will also do the same thing, except here this will take the number 2 and put that as the next entry in the list and add that to the end of the list that we defined up here. And then same thing on line 31, and then same thing on line 32. So if we run these statements in order, this 9 will be added to the end of the list, and then that result we then append 2 to, that result we then append 6 to, and that result we then append this 5 to. If we want to see what the list looks like after running all those append commands, we can see that it does in fact add those items to our list in the order that the program reads them. So again, the 9 got added to the end of the list, then we took that and added 2 to the end of the list, and then we took that list and added 6 to the end of the list, and then we took that list and added the 5 to the end of the list. So the append function is a great tool if you want to add information to a Python list. And I'm actually going to go ahead and keep this print statement in focus because another function that I want to talk about is the sum function. And what the sum function does is, again, you give it a list of numbers. So in this case, we have a list like what we have here on line 28, which also is a list of numbers. But one thing that we should keep in mind is it's actually not this list of numbers. This is actually, at this point in the program, the list is equal to this over here. That is this portion they have highlighted in the console, because we're taking our list and appending a bunch of numbers to it. So once we get to this point on line 35, our list is actually equal to all of that. And what the sum function does is it takes a list of numbers and just adds up all those numbers together to get one giant sum. So if we take that function and apply it to our list here, then we get 3 plus 1 plus 4 plus 1 plus 5 plus 9 plus 2 plus 6 plus 5. Add all those numbers up and get a result. And here we're just going to simply print out what that result is on line 36. So again, this is a list that we're applying the sum function to, and it turns out if we add up all those numbers, we get a result of 36. And the last function that we're going to cover as part of this segment is the sort function, which is something that you can again use on lists. And the way that the sort function works is it takes all of the entries in a list and sorts them in ascending order, that is from lowest to highest. And if we want to see what sort of result we get back from that, you can see this is the original list that we started with when we get down to this point in the program, and you can see this is the result we get back from telling the computer to sort all of those items in the list. Again, it's sorted in ascending order, that is from lowest to highest. Now, something else I should also mention about sorting is sorting a list is actually something that can become very computationally expensive very quickly. And by computationally expensive, I mean it requires a lot of memory and processing power to carry out that operation. And it turns out that as the number of items in a list increases, the processing power required to sort that list actually increases quadratically. So if you go from 10 items to 20 items in a list, that is, you double the amount of items in the list, the time it takes to sort that list actually quadruples. It doesn't double, it quadruples because it's actually a quadratic dependency. So kind of just taking that point a little bit further, if it takes, say, zero point 0.1 seconds to sort an item or sort a list with 10 items in it, then a list of 20 items will take 0.4 seconds. A list of 40 items will take 1.6 seconds. And you can see as the number of items in a list gets bigger and bigger, the time to sort that list can get very large very fast. So just something to keep in mind when you're working with the sorting function. This can be very computationally expensive if you tell it to act on a very long list of numbers. But one of the other nice things about a sorted list, something like this, you can actually make the process of searching for items in the list much more efficient. But those are just some sort of side notes that I want to mention about sorted lists. One, it's computationally expensive, but one of the advantages of a sorted list is you can actually make searching through the list more of an efficient process. And one other thing that I'll go ahead and mention, so we've taken a look at a lot of functions, and it might be kind of hard to memorize and remember everything that every single function does. One of the nice things about Spider is you can actually, if you forget what a function does, you can actually go into the console here and type a question mark and then the name of the function that you want information on. And if you do that, then here it will just print out all that information. So here, with a single iterable argument and its own jargon, fancy schmancy language, with a single iterable argument returns the smallest item. And this is just something to sort of demonstrate how if you forget what a function is, you can just simply type this question mark followed by the name of the function. And here in the console, you will get a summary or an explanation of what that function does. And for many Python modules, like the math module, this also works for those functions as well. But that's going to do it for this segment on some built-in functions. And like I said, this part right here, the idea of working with external files, is something we will cover in much greater depth when we get to the week 7 unit. But that's going to do it for this segment on functions that are built into Python. And we're going to take a look at one final segment that takes a look at a special type of function called a casting function. So with that, I will see you all in the final segment.